Hello everyone, welcome to my channel Dr. Tapati's presentation. Myself Dr. Tapati Vanjade. Today in this video, I am going to give you general equation for nth order reaction. You will know the answer for why is the order of reaction not greater than 3. I am going to give you few examples of n greater than 3 order reaction. You will know about fractional order reaction and negative order reaction. Let's know about the general equation for nth order reactions. For any reaction of the type Na to products conversion where n is greater than 1, the integrated rate equation has the general form, that is 1 by n minus 1 into At n minus power of n minus 1, that is equal to 1 by n minus 1 into A0 power of n minus 1 plus kt. Now we can write this equation in this way also. At is equal to A0 divided by n minus 1 root over 1 plus n minus 1 into A0 n power of n minus 1 kt. So for an nth order reaction, if you plot 1 by n minus 1 by 1 by n minus 1 at power of n minus 1 versus time curve, you will get a straight line with positive slope k, because this equation is like a straight line where y value is 1 by n minus 1 into at power of n minus 1 and x value is t. And in that straight line equation, you will get y-intercept, that is c value, as 1 by n minus 1 into A0 power of n minus 1. Now, in this way, you can get t half for nth order reactions, that is 2 to the power n minus 1 minus 1 divided by n minus 1 into k A0 power of n minus 1. Now, if you put n is equal to 2 in this general equation, you will get 1 by At is equal to kt plus A0. We are putting n is equal to 2 in first equation. Then you will get general equation for second order reaction, that is 1 by At, that is equal to kt plus 1 by A0. Or if you put n is equal to 2 in t half equation, you will get, in case of second order reaction, t half is equal to 1 by k into A0. You have to put n is equal to 2 in t half equation, and finally you will get t half is equal to 1 by k into A0 in case of second order reaction. Let's get the answer. What is the maximum order of reaction? Or in chemical kinetics, why are higher order reactions rare? Or why is the order of reaction not greater than 3? Theoretically, order of any chemical reaction can be any number, but practically, in the case of common reaction in day-to-day life, it varies from -1 to +3. Most reactions are below third order. So theoretically, any order of reaction is possible, but practically in common, in our day-to-day life, it varies from -1 to +3. We can find few third order reaction, and reactions of even higher order in greater than 3 are extremely rare. Why? According to the collision theory, the reactions occur due to the collision of the reactant molecules. In first or second order reactions, the probability of collision at the same time is quite high as compared to the third and higher order reactions. It is quite unlikely that 3 or more than 3 molecules will collide at the same time. Due to this very low probability of colliding of molecules, the higher order reactions are quite rare. Very few examples are there with above third order. We could not find an example of a fourth order in the gas phase, but in liquid phase there are a few of them, and even we can find fifth and sixth order reactions. Cross Cannizzaro reactions have order 4. This is an example of cross Cannizzaro reaction. Fifth order reaction example is reaction between the tetrahydrodecacarbonyl tetrahenium cluster and methanol. It's a big name. An example of sixth order reaction is in a catalyzed auto-oxidation of a macrocyclic cobalt 2 complex. Therefore, focus on zero first and second order reactions. 95% of the reactions behave like first 0, 1 or first order or second order reactions. Very few examples are available with a third order as well as above the third order reaction. There are few reactions where order of the reaction is fractional. What is fractional order reaction? Rate of the reaction is, in that case, rate of the reaction is proportional to the fractional power of the concentrations of the reactants. Examples: COCl2. COCl2 is the substrate and products are CO plus Cl2. In that case, rate is equal to K into COCl2 to the power of 3 by 2, that is equal to 1 by therefore the order of the reaction is 3 by 2, that is equal to 1.5. So in that case, order of the reaction is 1.5, that is fractional. If you consider the second reaction, here substrate is H2 plus substrates are H2 and Br2. Product is HBr. In that case, rate of the reaction is K into H2 power of 1, concentration of Br2 power of 1 by 2. So in that case, order of the reaction is 1 plus half, that is equal to 1.5. Now third example is conversion of CH3COH to CH4 plus CO. Here rate of the reaction is K into CH3CHO power of 3 by 2, and in that case order is 1.5. When Cl3 and Cl2 are substrates, products are CCl4 and HCl. In that case, rate of the reaction is K into CaCl3 power of 1 into Cl2 power of half. So order of the reaction is 1 plus 1 by 2, that is equal to 3 by 2 or 1.5. So these are the examples of fractional order reaction. Can the order of a chemical reaction be negative? If yes, what are negative order reactions? Give example. The order of a reaction can be either an integral value or fractional value. It may be positive or it may be negative. So answer for first question is yes. Negative order chemical reaction is possible. Now, what is negative order reaction? Negative order reactions are reactions where an increase in the concentration of a reactant or products means a decrease in the rate of the reaction. If you increase the concentration of the reactant or with the increase of concentration of product, there will be decrease in rate of the reaction. Example, the conversion of ozone to oxygen, 2O3 to 3O2. This process forms part of the ozone-oxygen cycle in the Earth's stratosphere and occurs in the excess of oxygen. It is occurred in presence of UVB rays from sun. There are two steps involved in this process. First step is conversion of O3 to O2 plus O. This is the first step. The second step is O plus O3, O plus O3 to 2O2. This is the slowest step and therefore it is rate determining step. Hence, the rate of the reaction is K into O. You have to consider step 2 reactant concentrations. So, rate of the reaction is K into O concentration into O3 concentration, because second step is the rate determining step. But first step is in equilibrium. You can see that it is in equilibrium. Hence, K equilibrium is equal to concentration of products divided by reactant. That is, concentration of products means concentration of O2 into O divided by concentration of substrate, that is O3. Or we can calculate concentration of O is equal to K equilibrium into O3 divided by O2. If we put O value in this equation, we will get that rate of the reaction is K into K equilibrium O3 into O3 divided by O2. Here we are putting value of this value we are putting in this equation, and final result is K prime O3 square into O2 minus 1. This corresponds to second order in ozone because power of ozone is 2, and minus 1 with respect to the O2 concentration. When a partial order is negative, the overall order is usually considered as undefined, because in this case, for instance, the reaction is not described as first order even though the sum of the partial orders is 2 plus minus 1, that is equal to 1. Here total overall reaction order should be 2 plus minus 1, that is equal to 1. But because the rate equation is more complex than that of a single first order reaction, it is not considered as the first order reaction. Thank you very much for watching this video. Kindly like, share and subscribe this channel. Don't forget to press the bell icon to get the notification for new video.